Well, 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 if it isn't Twitch chat. How's everybody doing today? Can you see or hear me right now? Let me know. Excellent. Looks like we're working. Beautiful. Well, welcome back out to the field, everybody. It's good to have you here. Happy Monday. I hope your week is off to a good start. And if it's not, I hope I can help improve that in some small way. But I'm out here again with the Utah State University Eastern Prehistoric Museum. Right here near Moab, Utah. We're miles and miles away from Moab, Utah, but that's the nearest town to where we're at. And we're digging up more dinosaurs. We've got some armored dinosaurs. You know the drill, but we'll talk about it as people trickle in. It's good to have you here. If anybody happens to be watching for the very first time, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here on Twitch trying to do some good old-fashioned science outreach. So whether it's back home in the office, going over new scientific papers and interviewing other paleontologists remotely, or whether it's out here in the field, hanging out with paleontologists in person, digging up fossils, collecting data, doing field work live on camera. This is, what I do. This is how I do science outreach. And I'm glad you're here. If you've got any questions at all, don't hesitate to ask. That's kind of the point of these broadcasts. Got you right here on my wrist, chat, and I'll do my very best to interact as much as I can with you, answer your questions, explain what we're doing, trying to give you an inside peek into how paleontology really works, So again, I'm glad you're here. How is everybody doing? Yeah, and it's a mighty fine hat. Thank you, Rothgar. I got this hat, when I was like 16 years old. I'm no longer 16 years old. It's been a long time, but I've worn this pretty much every field season. I think every field season that I've had. I've been digging dinosaurs since 2011, almost every summer. Sometimes multiple different seasons every summer. This is, holy cow, season number 4 this year. We had 2 non-consecutive weeks in St. George, Utah, back in March and April. And then a whole month, 5 weeks out there in Wyoming, from the entire month of June going into July. Well, May going into June, going into July. And then 3 weeks, a few miles that way at Doling's Bowl in the Cedar Mountain Formation. And now it's going to be 2 weeks out here in the Cedar Mountain Formation at Lori's site. So that's a total of 9 weeks this year? 9 weeks? 11 weeks? What was that? Hang on, let me think for a second. 2 weeks in St. George. Let's be conservative and say 4 weeks in Wyoming. So we're up to 6. Plus 3 over there. It's up to 9. And then 2 here. That's 11 weeks. Holy cow. How much does a shade tarp cost, by the way? Wondering if I could help, says Daily Dasp. Let's go ask Josh, actually. We got, I think, the last of our shade tarps just set up. So these ones you saw yesterday. This is where I was working yesterday. A little bit of work that I did on camera. And then we got these ones set up today, just this morning. This is important because there's a lot of UV out here, a lot of sunlight. It gets hot. It was in like the mid 80s this morning. It's probably up past 90 now, I would guess. We can check. Yeah, there we go.
Type the letters over it. When they've done a typo and they come back and they write a bunch of letters over it so that it'll look like it's moving. So
here we've got Jeff and Alyssa and Expedition Leader Josh right there in the Prehistoric Museum. Josh, we had a question. How much do these shade tarps cost? Got somebody considering a donation, I think.
How much did they cost? I think, let's see, the poles are $10 per 10-foot section.
Mm-hmm. Wait, $10 per 10-foot section?
Yeah.
That's really good.
Are. Yeah, they're not bad. You get those at the hardware store.
Yeah. I got this back home. They were like 3 times as much.
Oh, really?
Yeah.
Let's see. I have to look at a receipt. I don't remember.
But they're less than you would expect, I think.
They're not bad. Yeah,
They do get destroyed by UV after long enough, but
they
UV
do.
and wind.
The regular tarps do. The mesh ones,
they hold up a bit.
Those things are indestructible, but I'm sure those are more expensive. Those are just ones that we had laying around the museum from probably 20 years ago.
Nice.
But yeah, these white tarps are new.
Polyvinyl ones.
Yeah, I have to look them up.
Yeah, no worries. Yeah. But
I'll do that on my email real quick.
Awesome.
Using your Wi-Fi.
Excellent. Yeah. I put it on a taller pole over there, so we should get better signal over here too.
Nice.
Yeah. But yeah, if anybody's feeling generous, you know, museum could always use donations. This sort of work, I was gonna say, it isn't cheap. It is cheap in the grand scheme of things. Paleontological fieldwork doesn't cost a whole lot of money, especially when you compare it to other branches of science. But that means that every dollar does make a big difference, and it can make a big difference. We appreciate any support that we get.
I ordered 8 tarps for $191.
Holy cow, that's pretty good.
Yeah. Let's do that high-powered math on my calculator.
Yeah, that's
192 divided by 8. About $24 a pop.
$24 a pop.
With
Not
tax.
too shabby, yeah. Yeah, so for what, $30, you could get us a new tarp. That'd be pretty awesome.
Yeah.
These things are lifesavers. Yeah. Why do you think these are important, Josh? Like, give us your spiel on the tarps.
2 reasons. Number 1, so you don't bake your paleontologists.
Yeah.
Cooking your volunteers is usually not a good idea. I try to do things like fajitas and spaghetti and stuff like that. I don't want to cook my volunteers.
Spaghetti last night was excellent, by the way.
Yeah, it's all about that Italian sausage. Throw that in there, a few other secret flavor babies, and it's great.
Even the vegetarian stuff was really, really good, so I appreciate your pasta acumen. Yeah.
Yeah, and then what else? Really, for a site like this where it gets dusty, even though the bones and the rock are different colors, it can get dusty, and seeing the contrast is a challenge. So having kind of a good neutral light that's consistent, that doesn't change with clouds coming over or the brightness of the sun, the angle of the sun, that really helps get your eyes focused on, oh yeah, that's a bone, that's rock, and that just helps us more safely dig up the fossils. Yeah. Like we were over here yesterday, Jeff and I, kind of starting to clean this up, and I kind of had an idea, and looking at the map, I knew where everything was and roughly what everything was, but it was still staring at light-colored bones, light-colored rock with the sun glaring back at me. Today it's easy, seeing what all we're working on. So that's probably the most important thing for this particular site is looking at the contrast between bone and rock. But having the shade, it's probably 5 degrees cooler under this.
It makes a huge difference. Yeah,
it's a big deal.
Cool. Thanks, Josh. Yeah. Awesome. So I always talk about how important tarps are. I wax lyrical about that, and so does Dawn DeBlue. But it's good to get that perspective from other people too, so you know what, we're not just making it up, But yeah, and
on the
bottles policy. There you go, Claire. Yeah, it'd be really cool if they could get a sponsorship from Plockman's Mustard, Get some proper glue conveyances rather than those Nalgene's. But we'll talk about that later. I don't want to bug Josh right now. But I think he'd find that story amusing. He's probably got similar stories. Yeah. But yeah, good stuff. And thank you for those bits. Really appreciate that. Ms. Art Rules says, my question from yesterday for everyone in the field was, what's your favorite hand lens brand? Oh boy, I don't know if I'm really brand loyal when it comes to hand lenses. Let's see what mine is. I'm not even sure what it is. Might not even say. No, I'm not seeing a brand name on mine. Yeah. But I've got that, and then I've got this one for you, chat. This pocket. But yeah, these are, I don't know if they're branded, they might just be generic. But if we need to look up at a fossil up close, I've got this for you right here. Check that out. I had to grab that out of my tent this morning, so we got it now. Yeah. But yeah, I don't know if hand lens brand is really a consideration. I don't know if people are gonna have strong opinions about that, Ms. Art Rules. Yeah. And And how long are you digging? I might send a $50 donation if my finances allow. I appreciate that, Daily Dasp. Yeah. $50 would buy us 2 shade tarps, potentially. Or some food for the volunteers, or some digging equipment, stuff like that. It kind of just depends on what we need in particular. But, yeah. The Prehistoric Museum in Price, Utah it's a small organization, you know? This is not an AM&H sized institution. This is no Smithsonian or anything. It's a small regional museum. But because of that, you can see that there's little overhead. Like, any donation that you make, it's going to go directly to what we do. Especially if you earmark it and say, hey, I want this to go toward, paleontological fieldwork. I want this to go toward preparing these fossils in the laboratory that we're digging up this year. I want to make sure these fossils get cleaned properly. Kinds of stuff like that. So, yeah. I'm taking a look at these clouds right now along the horizon. And that is a little bit concerning. Because when we get storm clouds that come through here, the storms come from the west and they blow east. So that one looks like it could be poised to hit us in, I don't know, an hour or so. So cross your fingers, chat, that doesn't get us, because that looks like it might be full of rain. Yeah, this could get interesting today. We'll have to keep an eye on that. Luckily, we've got the internet up so I can stream, but that also means that other crew members can track the weather radar. We had that big old cloud over there that looked like it might have been poised to get us earlier, and it has passed us by to the north. So we got lucky there. That's probably dumping rain all over the book cliffs right now. So again, live broadcast, anything can happen. We shall see. And anywho, any Brita here? I'm not sure what you mean, Crimson. Yeah. And hey, Filippo, how are you doing? Hello. Filippo, yeah, I've got somebody here you might know, actually. We were just talking about you the other night. Yeah, and thank you, Casey, sending dry thoughts. Appreciate it. Yeah. Filippo, how are things with you? And hey, Cade6118, what's shaking with you? Good to have you. Take you down to the quarry here. We've got bones and things to show off, I suppose, if you'd like to see. There we go.
I would love to see that.
This is where I was working earlier. We've just got... It's a crazy thing. We've got bones everywhere here, like we were talking about for the past couple days. Right here is a rib. Looks like it's probably T-shaped in cross-section. A classic ankylosaur rib. And then, what do we got over there, Eric? That's the thing that could be a fibula, I think, to your left. That's what we were thinking, maybe?
This?
Yeah. But we won't really know until we expose more of it.
Yeah, there's a larger plate of bone right here.
Nice.
Too, that I just started uncovering, so I don't know.
Oh, interesting. So that one might flatten out.
Yeah.
Maybe that's a tib next to it. Yeah.
Maybe.
Yeah, maybe.
If it's a fibula, that would make sense if there was a tib.
Yeah.
And this could be like the proximal end where it really flares out, so we'll see what happens.
Interesting. Cool. Yeah. And then, let's see, I was exposing this osteoderm earlier right here. I think it's an osteoderm, but we'll see. Armor plate from an ankylosaur. But just about everything that's this kind of purplish color right here is bone. And we've got little pebbles mixed in there too, just to make things extra confusing. But yeah, this stuff is just everywhere. There's bone all over the place. It is nuts. Anything new over there, Jake?
Nope, it's mostly just been clearing out the top layer down so we can figure out where this mess actually ends.
Nice, yeah. Figure out where we can actually put the margins of a jacket.
There's a couple things from this morning of like these ossified tendons, we think.
Yeah,
kind of running through here. Which is very fascinating and interesting to find. But, yeah.
Nice. Very cool. Yeah, and then we got Michael here too. Filippo Bertozzo is in the chat right now.
Howdy, Filippo.
Hello. But yeah. And I'll see you later. But says, "Oh, Michael."
Howdy.
Yeah. Again, congrats on your new iguanodontid. That's pretty exciting stuff. I hope you've been getting more good press about that, more interviews and stuff, more press coverage. Yeah. And we've got a question from TDA Penguin. What's the typical magnification on hand lens used in paleontology? It depends. People have got their different preferences and stuff. I think mine is like a 10 times here, I think.
This is 10 times.
10 times? Yeah.
10 times seems to be standard based on what we have today.
Mm-hmm. But yeah. Again, a lot of this stuff is personal preference. We've got communal gear over here, although some of this is not communal, I think. And then some people have brought their own digging equipment. I've done some of that, and yeah, I don't know. But you work with what you've got. But yeah. And do you have enough sunscreen? I definitely do, Daily Desk. Thanks for being concerned. The nice thing about these shade tarps, too, is we don't need as much sunscreen as we would if we were in direct sunlight, too. Don't need to apply it quite as often. One of the many benefits of a shade tarp. We also don't need to drink quite as much water if we're not baking under the sun. So it's a good thing, too.
Still should go.
Oh, yeah. Yeah.
Would you hand me my water bottle, actually, now that I'm thinking about it?
Yeah, I got you.
Thanks, man.
Nice.
Hydrate.
Hydrate!
I should go do the same thing. I like the paracord handle on that. That's cool.
Oh, yeah, no.
Did that come with it, or did you make that?
It came with it. I got it at like a bargain bin sale at like Kohl's or some shit.
Nice.
Some
Yeah.
crap, sorry.
That's okay. But yeah. Is the karaoke gear mandatory? How do you know about the karaoke gear? Who told you that? Not quite mandatory, but it's one might say essential.
One might say.
And let's see, evil. What a great username! They say I'm thinking of going fossil hunting, and just looked up what I can find is Parapuzosia ammonite. Interesting. I'm not familiar with that genus. Yeah, I'm not an ammonite guy, but shoot, if Papa Jim were here in the quarry, he'd be like, "Oh yeah, Parapuzosia. That's from the, lowermost Campanian or something like that." I don't know. Jim worked on ammonites for a long time, and ammonites are really cool because not only are they just fascinating animals in their own right, but they're really helpful with biostratigraphy. Before I explain what that means, let me explain what an ammonite is for anybody in the chat who might not be familiar. Picture like an octopus, with a head and eyeballs and tentacles, but then it's inside of a spiral shell, almost like a ram's horn or something. In fact, I think that might be where the name ammonite comes from. I think it's from like ancient mythology. Wasn't like Ammon some sort of deity, and then the visual representations were like, a ram's head with horns or something like that. It's a coily shelled cephalopod. Although not all of them are coily shelled. Some ammonites had long straight shells, some had really weird paperclip shaped shells, all kinds of cool stuff. But anyway, ammonites are really neat because they evolve really quickly, and they're pretty common, and they're really well constrained stratigraphically. So what that means is that very clever, talented, passionate people have been able to figure out where these different ammonites come from in the rock layers and map that out. So we basically have like a time map of when these different critters come from. And so if you find a particular kind of ammonite, you immediately know what age the rocks are, because they don't last for very long. Different species will they'll evolve and they'll stick around for a while, and then they go extinct. And so they're really, really helpful for finding your place in time. If you find a particular kind of ammonite and you know how to identify it, you can figure out exactly how old those rocks are. We call that biostratigraphy. Bio, like biology, living things, because ammonites were once living things. Stratigraphy is the study of these rock layers. and how they correspond to time. So biostratigraphy, it's really important stuff. Not just for understanding the history of life on Earth, but if you want to be really mercenary about it, it's really important for stuff like oil and gas exploration. If you're trying to figure out where you might find stuff like petroleum, or coal even, or natural gas, well, you got to know how old the rocks are. You got to know a lot about that. You can use things like fossils to help figure out how to find oil. This is really common back in like the 1970s, and then there were a bunch of paleontologists who had been hired by oil companies to help go explore for new deposits, and then once they started to figure a lot of that stuff out, they fired most of the paleontologists, unfortunately. So there was a time when you could make a really decent living as a paleontologist, working for the pollution factory, but I think those days are mostly gone. But yeah. And let's see, Omanite Pokemon. Yes, so I think that is Ammonite to a certain extent. And you bet, Evil Squirrel. Yeah. So you should look up that genus of Ammonite. Yeah, if with the right charts and stuff, you can figure out exactly how old those rocks are if you know that those are in your region, which is pretty cool. Yeah. And let's see, Parapuzosia. Let's click that real quick, shall we? Desmoceratid ammonite from the Cenomanian to the Campanian of Africa, Europe, and North America. Very large ammonite, 60 centimeters or more. They can be up to 2 meters for 6 feet across. That's nuts. Super cool. Yeah, check out that picture. I don't know if you could see it with the glare, but there's one next to a human man. You can see it's much bigger than he is. It does make me wonder. This is something that I'm curious about with ammonites. How long do they live, Because I know a lot of cephalopods nowadays, they've got very short lifespans. If you know a thing or two about octopus, you probably know that octopuses, they typically only live for like a year. That's their entire lifespan. Some of them, like the giant Pacific octopus, are like 2 years, 3 years, something like that. But they reproduce and then they die. I wonder if we have an understanding about ammonites that takes that into account. Like, did they live fast and die young, reproduce once, and then kick the bucket? I don't know. I don't know enough about ammonites to know what the consensus is there. It'd be cool about that, because those giant ammonites, like, what was it, Parapuzosia? 6 feet across, 2 meters across. Is it growing that big in a year? I find that pretty doubtful. So how long did they live? And could they reproduce multiple times while they're alive, or did they just reproduce once and then die? I don't know. These are interesting questions. I'd love to talk to a specialist, Yeah. And yeah, Lunia Rose. I was reading a really sad article the other day. There was an octopus at, was it the Long Beach Aquarium? Who was really, really beloved by guests, really well known, popular on social media, and she just laid a bunch of eggs that are not going to be fertile. They're not going to result from that because there was no male involved. Eggs, and she's now in the process of dying, and they've taken her off of exhibit, and people are just heartbroken over this because they've grown really attached to this octopus. It's a bummer, It's a beautiful animal, it's incredibly intelligent. If I could recommend a documentary to you real quick, there's this wonderful, I think, PBS special. I've talked about this before, called Octopus in My House. Pretty sure that's what it's called. And you might be able to watch it online for free if you're here in the US. But yeah, so there's an octopus scientist, somebody who studies like cognition in octopus, I think. And during COVID, during the lockdown, he had an octopus delivered to his house. He lived up in Alaska. and it's just in a tank in the middle of his living room. And so he and his daughter are just going about their daily lives during COVID with an octopus there in the middle of their house. And they're interacting with it, and it's interacting with them, and they really get to know this animal, get to know its person. It recognizes them, it's got all these cool personality quirks, and it's really fascinating. I would highly recommend it. As human beings, we can often be so anthropocentric, you know? We think that any animal that has any degree of intelligence, we think about it on our own terms, you know? Like, oh, it's got to be human-like, of course, right? Like when we try and imagine, you know, hypothetical intelligent beings on other planets, they're always humanoid in shape, right? But we have other intelligent creatures right here on our very own planet that look very, very different from us. And while they're really clever, they're clever in a different way than we might expect. It's interesting to think about, you know? So yeah, I'd recommend that. Octopus in my house. It was good stuff. But yeah, hey, Hang Loose, how you doing? Welcome. Good to have you here. Yeah. And Crimson says back in one of the World Cups, people were into an octopus that was predicting football results. Yeah, that was just sheer luck. The octopus didn't know anything about football. You know, they don't care about professional sports, just like me. It's one thing that octopus and I have in common. Yeah. Trek Nerd says, I always wonder about dinosaur personalities. Well, that's the thing, is lots and lots of different critters have different personalities. And I have no doubt that non-avian dinosaurs would have had different personalities too, you know. Because we see that today in their closest living relatives. If we do some phylogenetic bracketing, we can think about the closest living relatives of dinosaurs, which are birds, who literally are dinosaurs, and crocs, who are like cousins to dinosaurs. And after that, you get turtles, a little bit further out, like we talked about yesterday. But birds and crocs, and turtles for that matter, individuals will have different personalities, different preferences, different quirks. They'll grow attached to certain people and recognize them if you interact with them. They're critters that have feelings and presumably thoughts. You know, like I said, preferences and likes and dislikes, and you know, they've got, to a certain extent, rich emotional lives. We as human beings often forget that other creatures can have that. It's an important, like, perspective check, you know, to think about those other critters and realize that, you know, they have inner lives as well, like we do. Maybe it looks a bit different because it's a different kind of animal, but yeah, it's important to remember that, I think. Gives us empathy for the other critters that we share our planet with. Crimson says Triceratops were discriminatory against sauropods, and I totally didn't get that from Land Before Time. That's kind of funny because they didn't... I wonder if they would have lived together in any environments. Because Triceratops, when we get those in the Lance and Hell Creek formations, there's no sauropods there. I don't know if a Triceratops ever would have met a sauropod. Probably. Go down south where you get Alamosaurus at the end of the Cretaceous. I'm sure there are some Triceratops wandering around down there at some point. But yeah, we typically don't find them together in the fossil record. Certainly not. Yeah. And anywho, yeah. And Casey was drawing rhinos earlier today in honor of that. Oh, very cool, Charlie's Dragon. Yeah, I saw her post on Blue Sky. Can we get a shout out for Casey Snowart? She was doing an art gym stream in honor of World Rhino Day, which apparently is today. Super cool. Rhinos are such cool animals. Their closest living relatives are tapirs, and after that, horses. So a rhino is much more closely related to a horse than it is to something like an elephant. It's funny, we used to think, I say we, people who work on, you know, big mammals, they used to think that that elephants and rhinos and hippopotamus and other like large, thick, gray-skinned mammals, they used to think they were all related. There was a name for that group, the pachyderms. Nowadays we realize that's not the case. An elephant is much more closely related to an aardvark or to a sengi, an elephant shrew, or a golden mole than it is to something like a rhinoceros. So we've got a better understanding of how these animals are actually related today. But yeah, happy World Rhino Day to you too, Casey Snowart. Good old pachyderm. I know, right? Yeah. And Just Floof says, if this dig site offers a lifetime of work, from yesterday's talk with the foreman, John laughed to hear himself be called the foreman. Would that mean you can just hire a trainee with no PhDs to work here and help us? Absolutely, yeah. None of us here in this quarry have a PhD except for Josh. Yeah, that's everybody here is volunteering except for Josh too. He's the only one getting paid because this is his job. But yeah, we're we've got volunteers here right now who have zero experience in digging dinosaurs or any kind of paleontological work for that matter. We just need people who are willing to show up and people who are willing to learn, take direction, and develop those skills. Yeah. Like, we're not, this isn't like a gatekeepy kind of operation at all. Yeah. It's volunteer work, absolutely, Just Floof, yeah. Again, that's the thing, is that this museum that we're working with, the Prehistoric Museum in Price, Utah, they don't have the budget to hire a bunch of people. We're not getting paid to do this. I don't think I could, in good faith, ask for donations if we were getting paid to be here, you know? We are here donating our time because this is an organization that doesn't have a big budget, but we're doing important work and we think it's worth it. So, yeah. And daily daspas, are humans related to more than just primates? Oh yeah. Yeah, shoot. Here, let's talk a little bit about phylogeny, shall we? Yeah. Here, let me get some water and then we'll break out some of our visual aids here. Get our tree of life. Oof. It'd be a lot easier if I were back home in my office. We could just pull up one zoom. So, should be inside my clipboard aids. Humans, of course, are a kind of primate, or primata. That's the name of that clade. But then there's other clades that are related as well, and I'll kind of walk you through some of those. But first, I should say, since there are probably people here who are not familiar with this concept, the concept of phylogeny. We as scientists, when we classify living things just based on vibes, we're not just doing it based on what looks like another thing or, you know, do they feel similar or whatever. When we say that two different critters are related to one another, we mean that literally. We mean that they shared a common ancestor at some point in the near or distant past. And the closer related two different organisms are, the more recently they shared a common ancestor. So think about it like your own family tree. You know how like you're very closely related to your siblings, presumably, and you share a recent common ancestor. So chances are you share the same parents as your siblings. That's a very recent common ancestor. You got the same parents. But you're not as closely related to your cousins, if you have cousins. You do share a common ancestor with them, that's your grandparents. You and your cousins have got the same grandparents. You can do that further out and further out until you get to all of humanity. And you can do that further out and further out until you get to all living things on Earth, in fact. Because as far as we know, all living things on our planet stemmed from the same common ancestor several billion years ago. Probably about, 2 or 3 billion years ago, something like that. So this concept, thinking of of living things, relationships like that to each other on a big evolutionary tree of life. This is called phylogeny. So yeah, here's an illustration of that right here. So here's humans right here. This is kind of like an evolutionary series. You get to some other primates there like chimps, marmosets, lemurs, that are outside of primates but closest to primates are rodents. So humans are part of genus Homo sapiens, you know. There used to be other species within Homo as well. Homo neanderthalis, or neanderthalensis. Homo heidelbergensis, etc., etc. Then you get out into the other hominids, well, members of that family, outside of genus Homo, things like Australopithecus and stuff like that. And then you can go further out down the tree through the rest of the primates, and then the group that includes primates and things like rodents and lagomorphs is called Euarchontoglires. And I realize it's a long, complicated word, but that's the group that includes primates and their closest relatives, things like rodents, rabbits, etc. Yeah, and then you can go out further from that, and there's other groups, and you keep doing that until you get to the, until you get to all of life. It's pretty cool, like, thinking about these things. Like, when you're a paleontologist, or a zoologist, or a biologist in general, or just, a curious person, when you learn about these concepts, you kind of see life in a new light. When I'm walking around this landscape, I can think about my relationship to all of these other organisms. Whether it's a kangaroo rat that I see skippering across the ground, or whether it's something a little bit more distantly related, like, say, a lizard or a bird, or something even more distantly related than that, like some of this sagebrush or this ephedra right here. I and you too share a common ancestor with this plant right here. You got to go way, way, way far back in time to get to that common ancestor. This would be like well over 1 billion years ago, I think, before the first animals evolved, or before the first true plants evolved. But there is a common ancestor if you go back far enough in time. That's part of what we as paleontologists do, is we're trying to figure out how all these different things are related to one another and when they evolved, when those splits on the family tree took place. Because all of this is important for understanding the history of life, So yeah. But yeah. On Glires, there you go, Charlie's Dragon, yeah. But yeah. And it is Mormon tea, exactly, Claire Burr, yeah. Very appropriate for Utah, I suppose. It's good to see you too. Welcome. Yeah. And here. Family of fungus. There you go, Fall Machine. Yeah. Don't think about it like your family tree. It is your family tree, says Treckner. That's true. Yeah. And biologist here, says Journey Reviews. Excellent. Hey. It's good to have you here in the chat. Thanks for joining us again. Yeah. Generate views with pleasure. I appreciate it. Again, good to have you here. Yeah. Anywho. The word pedigree, which is now mostly used for domestic animals like dogs, literally means crane's foot. Does it really? Yeah, I guess gray? Yeah. Ha! Cool. That's really neat. Anywho, let's get back down into the quarry real quick, shall we? And take a look at some things. Let's see. I'm gonna drink some water first, though. I'm pretty thirsty. It's a dry day today. I wonder is the humidity lower today than it was yesterday? I bet you it is. Let's do a quick temperature and humidity check, shall we? And oh man, it is starting to look like those clouds are gonna get us. It might be an hour from now, might be longer, but yeah. All right, temperature and humidity, 91 degrees Fahrenheit, 90. 89, okay. And 19% humidity. Oh, 20%. Okay. Yeah. So that's still kind of high for this area compared to what I'm used to. Again, when we were working in Doling's Bowl, just a few miles that way, last month, we got down to like 3% humidity, I feel, at one point. It was crazy low. Almost no moisture in the air. That's it was a much drier environment than this here, but far positively lush by comparison.
Is that the idea for this side? I know over there we were trying to minimize big blocks.
Yeah, I mean, we successfully, like, here last year, pulled out, like, a meter and a half size blocks.
All right.
So yeah, that would be great if we could do that, but sometimes it's hard.
Sweet.
Erica, how's your spot?
I feel like trying to get down. Lifting this off real carefully, but I've covered all of this. It's continuing there. There's a plate here that looks.
I don't know, that corner right there looks like it could be an ischium, but maybe
here?
not. It could all, yeah.
I mean, 'cause this
Just
isn't
how
bone.
rounded that is, I've seen that
Right,
on,
that.
yeah.
Yeah.
But I could also turn that into a busted up
Any
ulna
chance it
even.
being, like, plant fiber?
So, a couple of things it could possibly be.
Okay, cool.
Who knows?
Yeah, I'm gonna
The
try to
fact that
get
the
this
color is
back to
super
here
duper
and then
weird
see what's
compared
happening.
to all the others.
It wouldn't be so weird
I
if
was
it
thinking
wasn't
of
in
working on
direct
this,
proximity
too.
to other
Yeah.
ones.
Yeah,
What
that
do you
would
want
be
to
good.
do with this
Are-
vert that's just like, hanging out?
And that's
We'll
It's very-
I mean, it's
map-
fine there for
Yeah,
now.
yeah.
I'm not gonna-
Unless you need to,
I don't
if you
know.
get to a point where you need to move it, we'll map it in.
Okay.
But yeah, until
Alright.
then, you can just leave it.
All right, cool.
Does it seem to pick up right now so I can show the camera maybe?
Sure.
Josh, yeah. I think it's a caudal.
Maybe.
Nice vertical.
Yeah, it is.
Yeah.
Yeah, there's
Okay.
the transverse. Yeah, it's a little
Nice,
squished.
okay.
Little caudal vert.
So is that dorsal-ventrally compressed? It's been squashed top to bottom?
Yeah,
Looks awful flat.
yeah.
Yeah.
Which, most of them we find out here are.
Yeah.
So that's pretty normal.
Nice.
And I mean, they're pretty short and squat like that anyway.
Yeah.
But, yep.
Pretty neat.
Yeah. Not a bad one.
Well, I was amused by this. Somebody in the chat referred to you as the foreman from yesterday.
The foreman.
I was trying to find the words to describe Josh.
That sounds about right. It sometimes has negative connotations because my dad worked in manufacturing.
Uh-huh.
So it's like, the foreman's normally can't say that.
The boss man.
Yeah, so I don't know. Maybe they are. Maybe they're like, yeah, this guy's a foreman.
I don't know. Josh is, as much as he is the boss, he's, he doesn't lord it over us or anything like that. So we appreciate that. Yeah.
Yeah.
But,
You're saying it's 16 tons before too.
yeah. Foreman said, well, bless my soul.
Sweet chariot.
Down and do a little bit of digging. If nobody minds bringing the camera in for a little while.
Not at all.
All right. Set that down there. Set this here. Hopefully we've got decent signal there.
It's a little iffy down here in the pit.
What's that?
It's a little iffy down here in the pit.
And I'm gonna be yapping a whole bunch and annoying everybody. Let me just empty that bucket for you.
Oh, that's great. Thank you.
Yeah.
It was getting out of hand, and I don't like standing up.
Well, we got bones everywhere too. It's like,
How do I even move from
It's
A to
getting
B?
a little like hanky as far as where to go.
yeah.
Yeah. We gotta do a whole ballet dance to get around.
Very good signal here. Excellent. Yeah. bring the camera over and show this off. There's our big rib again right there.
We continue to get stranger.
And here was that osteoderm that I exposed earlier. I think it's an osteoderm just because I don't know what else to call it. So, right here, armor plate from one of these critters. This almost looks like it could be either a phalanx or a vertebra here. And then
The orange bone.
other random bones. This looks like it's probably another osteoderm.
Like broken off of something?
Here's another bone here. This looks like a rib, or maybe a transverse process from a vertebra.
Huh.
But it's
That could be ossified tendon. There's just stuff everywhere. It's just all over the place.
Okay.
And we're also getting all of these. See that little pebble right there? And there's another one right here. It's really strange to see so many pebbles all over the place here. Here's another one right there. So it's bizarre because we've got this really fine-grained sediment here. It's, yeah, the grain is really, really fine. So typically when we get really fine-grained stuff like that, that's associated with like a really low energy environment, like a quiet stream or something maybe, or like a quiet lake. So to get that mixed in with all kinds of bigger clasts like these pebbles is bizarre. And yeah, shoot, Michael, would you want to talk about that at all?
yeah, sure.
Like why that's so strange?
Yeah. So if you want to come over here,
Yeah, let me bring the encoder over.
example of
Excellent.
what we're looking at.
Yeah.
So howdy y'all.
Michael
howdy again.
Chipone, is that how?
Yeah,
am I
Michael-
saying that right?
Depends on if you say it the American or the Italian way. Everyone says it differently.
Yeah.
Michael Chipone.
Chipone.
Capone.
Howdy y'all. In the quarry here, there's one spot that I believe Jake, you were the one who pointed this
Yeah,
out.
well,
right?
it was no close enough to cast where I think someone had dug it up earlier,
Yeah.
but I cleaned it up.
Of very fine grain, light silt, and maybe up to small, fine sand, surrounding all of these little bitty, relatively large actually, as far as pebbles go, lithic fragments, i.e. pieces of rock that have come from elsewhere. And they're all concentrated on this side of the bone here. You can see, something in the order of probably 20 or so, sort of looped around in here. And like Danny was saying, that's odd, because if you're thinking about sediment transport, I do a lot of sedimentology in my PhD work. You think about sediment by their ability to move in a water flow or not. And typically, you think about that relative to their size. A larger grain is typically, unless it's sufficiently low density, is going to be harder to move.
Right.
And so, if you mostly find a fine-grained sediment, that's typically going to suggest a relatively low-energy environment. Lakes, slow-moving water if there is any movement at all, wetlands, that kind of a thing. Think of the mud you find in wetlands. Whereas if you go out to a river, a lot of times your sediment can be a lot larger. It can be sand, it can be gravel, it can be cobbles even, depending on the speed of the water flow. And there is some basic math that we can run on this kind of thing to determine how fast the water was likely to be flowing. And so if we found a bone in this without finding these pebbles, and you just found a lot of this really fine-grained silt and sand, that would suggest that this bone was deposited and buried in a relatively low-energy environment. But we're finding both. And basically what that tells you is that in order to get here, because we know that the surrounding rock is not made of these little pebbles, these were transported some distance. We don't know how far. Could have been 20 meters, could have been 1,000, we don't know. But they had to move, which means that whatever water flow put this sediment here also probably put the bones here at the same time, and it had to be high enough to move these pebbles. And so we can use these pebbles as sort of a guide to how fast that water was moving. There's some basic math involving the size of the sediment, the depth of the water, gravity, 9.81 meters per second squared, and the slope of the river itself. In this case, we're out of a river, but the slope that the water is moving over. And you can use that to determine how fast the water was moving, what shear stress it imparted on the ground, and thus on the pebbles that it could move. So we can use that to know, hopefully I might try to mess around with this tonight, get the largest diameter of these pebbles, what are the biggest pebbles here, and determine how much water it takes to move something like that. Because that's going to tell us what sort of a water flow was burying our bones.
Right. And that's really important for determining like how far these bones are, like what's going on in this environment where you get all these dinosaurs preserved in the same place.
Absolutely. Not only there's a bunch of pebbles, but in this case, notice that they're all centered around the back, well, this side, your right, I believe, side of the bone. That indicates that this side here likely was the downstream side. As water was flowing, water moves around this bone here, and I've done experiments on this back in the lab, where water will move around the bone and create an eddy, which is basically just a vortex behind the bone that slows down. And as pebbles are, and the bone is essentially eroding itself underneath. This bone might not have been moving, but the sand around it was. And so as the sand and the pebbles, most importantly, reach this eddy section here, where the water is, moving in these vortices, they get caught and then deposited and unable to move again.
Right.
And so very likely that's how they ended up in this big pile of pebbles here. There are pebbles scattered throughout the site.
Right.
And that suggests that the water flow was likely this direction.
Very, very cool. Yeah. And so this can help us determine, like I was saying, how these bones were deposited. If this came over from a river or something like that, we can tell which direction the river was, essentially, if we can tell the water flow direction.
Exactly.
Super, super cool stuff. This is really neat. I mean, Chad, this is 130 million years old, and we can figure out the direction of flow from the water. That's pretty astonishing. Like, that's really, really cool stuff.
Yeah, this is why I like to joke that taphonomy, the study of how fossil material becomes fossil material, is sort of Jurassic CSI. We're piecing the story that got these bones here back together.
It's like investigating a crime scene. This is so cool. Yeah. Thanks, Michael.
Of course.
Really, really appreciate it.
Ciao, y'all.
Neat stuff. Yeah. Let's see if we got any other questions or anything. Didn't know that had a word, says Jared Interviews. Yeah, taphonomy. 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 Let's get a Wikipedia link for that. Yeah. Pretty neat. And we got a huge raid from Kuma Monster. Well, here, let me go do my little spiel and then come back into the quarry. But, yeah. Welcome, Kuma Monster and Raiders. How are you all doing? It's wonderful to have you here. Welcome to a live dinosaur dig out here in eastern Utah. We're digging up a bunch of ankylosaurs and trying to figure out how they got here, why they're all preserved in the same place. I'll show you in a minute what that dinosaur would have looked like. But, let me explain who I am real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. And I'm here on Twitch trying to do some good old-fashioned science outreach. I'm working out here with the Utah State University Eastern Campus Prehistoric Museum. And this is called Laurie's Site. This is the world's largest ankylosaur bone bed. We've got the highest density of ankylosaur bones anywhere in the world right here in eastern Utah, kind of near the town of Moab. If you're at all familiar with this part of the world, you might recognize the name Arches National Park. That's right over there on the horizon. Those rocks you see jutting up, that is the eastern edge of Arches National Park over there. So we're outside of it, but there it is. And shoot, if we were to walk a little bit that way past that ridge, you could see Delicate Arch on the horizon. But yeah, beautiful country. I love this part of the world. Yeah, I'm out here for the next almost 2 weeks now, digging up dinosaurs. We've got storm clouds approaching over here, so I don't know how much longer this stream is going to go. Stay tuned to find out, I suppose. we might get rained out here. But yeah, so the kind of dinosaur that we're digging up here, there's a whole huge accumulation of Gastonia bones. So Gastonia is a plant-eating dinosaur. Big arm. Well, medium-sized armored dinosaur, I'll say. From the early Cretaceous period, like 1 years old, and thus the dinosaurs in them are too. Here we go. Here is Gastonia right here. There's a plastic model. This is not life-size. In life, this animal would be about 15 feet long, about 5 meters. It's a tremendously spiky animal. I think these armor plates and spikes are to deter predators. Maybe to a certain degree also to show off to other members of the same species. But this is Gastonia right here. Really cool animal. And our follow alerts are Gastonia as well. Yeah. Who's the best dinosaur group and why is it ankylosaurids? Oh, don't let Gastonia hear you say that, because Gastonia is not an ankylosaurid. It's a polycanthine ankylosaur. So Ankylosauria is a big group of armored dinosaurs, and then there's smaller groups within that, more specific groups. You've got the Nodosauridae, the Ankylosauridae. You've got Polycanthinae, and according to Jim Kirkland, who works on these critters, there's some disagreement about how some of these things should be classified. But there's other groups too, like, what is it, the Sauropeltines, I think, and Struthiosaurs and stuff like that also. But anyway, Gastonia. Our particular species of Gastonia that we're digging up here is called Gastonia lori-mcquinii, or Lori McQuinney, however you want to say it. But that's named after a woman named Lori McQuinney. Lori McQuinney was prospecting around here with the Denver Museum in the 1990s, and she found this quarry. So she discovered this dinosaur in the first place, and it's been named after her, which is really cool. Yeah, down there in the quarry I've got the original descriptive paper for Gastonia lori-mcquinnie, and maybe I'll show you that if you really want to see it. It's not too exciting. It's just a printout, a scientific paper, but publications are kind of the currency of our science, so we get excited about that. We think a lot about publications. But yeah, oh, and then there's the parankylosaurs too, Dr. Tara, which, yeah, according to some researchers, might not really be a distinct group. It's yeah, that's like a lot of southern taxa, things from like South America and Australia and Antarctica, parankylosauria. We're still trying to figure out how all these different animals are related to one another, all these ankylosaurs. So that's there's not super strong consensus on a lot of that. But yeah. Oh yes, four-legged Bowser, says Prince Ninurta. Maybe. But yeah. And let's see. Seku-sama says plate armor. Sort of, yeah. And did we get another raid? Shoot, we did. Crack Eggs, hey, thank you and your raiders for coming in. Welcome. How was your stream? Crack Eggs and Kuma Monster, I hope you both had wonderful streams. It's great to have you here. My name is Danny Anduza. I'm a dinosaur paleontologist. We're digging up dinosaurs out here in eastern Utah. And, yeah, and hoping that storm doesn't hit us, but it looks like it might. We shall see. You can hear Michael set out his DSLR there. He's doing a time lapse. That's going to be awesome. I will be careful not to walk in front of it. Can you hear it going? Nice.
Josh said he's hoping that we're not going to get the worst of it.
Yeah.
So he doesn't want to drop the tarps.
Okay.
Just batten everything down.
Yeah. So he doesn't
He's
want to...
okay with like the zippy staying here,
Sure.
given that they seal.
Okay, good.
Cool. All right, neat. But yeah, hey, Raiders, let me know if you've got any questions or anything. I'll get back to digging in a little bit, but I figured we'd walk around for a minute, answer questions and stuff. Yeah. Ed Storm says, fascinating, love this. It's great to have you here. Welcome. Yeah. And Daily Dasp had another question. Do you have any idea on why there are so many, or is it a fun mystery? Well, that's true for a bunch of different dinosaur groups. There's just a bunch of different. Yesterday, we've got well over 1,000 different dinosaurs that are probably valid. There's like 2,000 or 3,000 different dinosaur genera that have been named, but not all those are legit. Sometimes the fossil material is just too fragmentary or poorly preserved to really confidently name a new species or genus based on it, but some people still do it anyway. So we get a lot of that. But with a dinosaur like Gastonia lori-mcwinniae, we've got so much material. Here from this site, we have a minimum of like 40 individuals. It's probably closer to 10 or maybe even 100 times more than that. Just here at this site. So many individuals from this dinosaur all got buried in the same place, and we're kind of trying to figure out why. But anyway, why I bring that up is we've got a ton of different bones. So nearly every bone from the skeleton is going to be represented here at this site. So that's why we're here, trying to find every piece that we can. We're collecting each of these bones for the Prehistoric Museum in Price, Utah, so they can be studied so we can better understand this dinosaur. Its evolutionary relationships, its lifestyle, its growth, what we call ontogeny, things like basic aspects of its biology while it was alive, its diet, its behavior, its, maybe its lifespan, all kinds of things like that. When you find a new kind of dinosaur, you're talking about an entire organism that species might have existed for 1 million years or something like that. And there's so much to learn, Think about animals today, think about, for instance, a Bengal tiger. Tigers, I think, are fairly well-studied animals because they're very charismatic. People really like them. But we have a pretty good understanding of how long they live, how big they get, what they eat, what their behaviors are, how they interact with one another, kinds of stuff like that. That's an animal that's alive today that we can study in person. You can pull it into the laboratory and take measurements on it, and you can watch it in the wild. You can track them as they're moving through their habitat with things like radio collars and stuff like that. With most dinosaurs, we can't do hardly any of those things. But the more fossils we find, especially the more individuals we find of a particular kind of dinosaur, the more we can start to understand things like, what did they look like? What did they eat? What's their individual variation like? Did they all look like exactly the same? Or are there interesting differences between individuals? All kinds of stuff like that. The larger a sample size you have, the more of those questions you can start to answer. So it goes from, here's a cool dinosaur that we just discovered. This thing existed, and that's roughly all we can say about it, to, we can start to answer real biological questions about this critter. That's what we're excited to do here. This is kind of paleobiological work that we're hoping to facilitate by digging up these bones here. How do they bounce around on their tails? There you go, Gene Wen. Yeah. Yeah. But yeah. Anyway. Let's see, other questions. If it rains, do you have to go, says Daily Dasp? It depends how hard it's going to rain. I mean, at the worst, we'll go back to camp and just hang out in our tents or whatever until the rain passes. But we also might want to help cover up some of these bones so that, they don't get wrecked by the rain, because torrential rain can soak into the rock that's surrounding these bones, and then it can basically turn to mud, and then you can have the bones crumble. We don't want that. So we might end up gluing some of these things a bit more, just so that we can make sure that if it does rain pretty heavily, the bones won't crumble, at least, We can soak them with a little bit of penetrant glue. Squiggle says every dinosaur dig is a murder mystery. It is, yeah. That's kind of like what Michael was saying, It's like it's Cretaceous CSI. Or maybe that's redundant. Maybe it's just CSI. Cretaceous Site Investigation. Yeah. Segusama says, do you call a group of them a herd or something specific? Yeah, we say group or herd. I don't know. There's a funny article about that, actually, from, what is it, Audubon magazine or something? Most of those terms that you hear for, like, oh, a group of wombats is actually called a wisdom. Bobolynx is called a florissant or something. Like, those are all meant, like, the only place that those terms exist is often in those, like, trivia books. Like, no one actually uses any of those terms. I think people maybe made them up for those fact books. It's annoying. Anyway, for groups of dinosaurs, we would say herd, or maybe pack, or just group, you know. Pack is often associated with predatory animals, so you might say that for theropod dinosaurs. But yeah, we would say herd, I guess, for these guys. But that's the thing, is that we don't even necessarily know that all these Gastonia lived in a herd. We don't know that they actually lived together. It could have been that they were solitary most of the time, and then they just happened to congregate for some reason and then die at the same place. Especially if this was a really drought-prone time and place where these guys lived. You know, if you've got a really bad drought, a lot of these guys that normally don't like hanging out together might have to congregate around a watering hole, and then that shrinks and shrinks and shrinks as the drought continues. These guys drink up the water and it evaporates, and then maybe there's no water left, and maybe they die of thirst, all in the same place. Normally, maybe these animals didn't want anything to do with each other, but they had to gather during a particularly bad drought year or something. We don't know. There's little that we can say for certain right now, but the more fossils we get, the more data we gather, the closer we get to being able to answer some of those questions. You know what I mean? Yeah. Let me scroll down. Let's see. Animal names get really silly, says Gene Wen. Yeah. Did we have a link to that article? Where was that? Yeah. Generating View says, how come we've never found any dinosaur cities? I think dinosaurs were pretty rural in general. Yeah. And Zool says, was there any form of seasonal weather changes? Maybe not to the extremes humans face, but maybe in the sense that caused dinosaurs to move around and possibly hibernated. Hibernation, I don't think we really have any strong evidence that any dinosaurs hibernated, but we do have evidence that they hibernated. Some kinds of dinosaur would have moved from one place to another during different times of the year. We just talked about this the other day, maybe yesterday. But we do have strong evidence that certain dinosaurs laid their eggs in the same place every year, or maybe every few years. But we know they would have had to migrate to do that, because you've got hundreds or thousands of dinosaur individuals all in the same spot to lay their eggs in a big nesting colony. It's like, they're not living there year-round. They eat up all the food. There'd be no plants left. They would completely strip the landscape clean if they were there year-round. They would need to move to find more food to sustain themselves. So we do have strong evidence that some dinosaurs migrated. But we don't know how common that is across different dinosaur groups, and we don't necessarily know how frequent it was, too. Whether it was every year or every few years or what, we don't know. Take, for instance, like leatherback turtles today, which I've been talking about a lot lately. But they'll return to their nesting beaches, at least in the Western Pacific. It's about every 3 to 5 years they'll return to the nesting beaches. They don't do it every year. Maybe dinosaurs were like that too. It's hard to say, you know? Yeah. Would mass swallow nestlings be considered a dinosaur city? That's a good question, Dr. Tara. I don't know. I think in order to be considered a city, you have to have decent public transit, and I'm not sure if they have that, you know? Yeah. That's what urban life means to me. Yeah. And Amstelvin, very funny. It's good to have you here. Welcome to Paleontologizing. I'll show you around the quarry in a little bit if you'd like to show you some of these dinosaur bones. It is very windy, Lapa New Year. Again, we've got some weather rolling in. Yeah. Any chance it was disease, says Daily Dasp? Maybe, but that's a difficult thing to demonstrate, you know? That's the thing about science is about testing ideas using evidence. You know, you can come up with a really nice story that might sound convincing. It might make sense outwardly, but it's not science if it's not testable, you know? And disease is one of those things where it's a tricky thing to test in the fossil record. Because what we have here are bones and armor plates and the teeth of these animals. But unless the disease that they had has some sort of signature in the bones, unless you can tell that they were diseased from the bones themselves, then you can't test that idea. You know what I mean? So it might be a nice story, but it wouldn't be scientific. Does that make sense? Yeah. So it's a possibility, but really tricky to actually demonstrate using scientific means. Yeah. Any sign of depressive dinosaurs? Again, how would that show up in the fossil record? Yeah. Yeah. That's a tricky one. Anyhow. Yeah. Let's see here. How are you doing in the sun? Sun's not bad today at all, Evil Squirrel. Yeah. I also put on lots of sunscreen this morning. We've had these shade tarps. Let me drink some water. That's one of my ways of dealing with the sun. And I'll show you around the quarry, because we've got some new folks trickling in too. Try and stay out of the time lapse there. Don't want to ruin that. Set on like a 1 second timer?
Do what?
A 1 second timer for the time lapse?
Oh, yeah.
Nice, that's gonna be awesome.
Yeah, I want to track the rain coming in.
Nice. Yeah, I'm hoping we don't have to evacuate, but I guess we'll see.
Hopefully so. We've got stuff battened down just in case, but
Nice.
taking the opportunity to do some science.
Perfect. Yeah.
Taking notes.
So yeah, here's the quarry, everybody who just trickled in. This is one side over here. We've got another one over there, under those shade tarps. The bones over there tend to be a lot bigger and less dense, which is potentially interesting. Might be part of this story for, like, you know, how the site came to be, how these bones got buried in the first place. Anywho. Look at how densely accumulated these bones are. We've got bone here, and here, 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 and here. This is an armor plate, an osteoderm right here. Not a particularly pretty one. But yeah. It's all over their bodies. They're just covered with osteoderms. And this looks like an ancient break right here, so what's interesting about some of these bones is it seems like they'd been lying on the surface for a long time before they got buried. And this looks like it might be part of that. We've got some of the matrix in there, some of this like surrounding rock stuff that's on the inside of this break, which tells us it's not a recent break, it's an ancient one. Here, I showed this earlier, but I'll show it again. Nice charismatic rib right here. So, see the edge of it right here? Yeah, it's nice to have that intact like that. I wonder if this could be the end of that rib right here, and maybe it broke off and was transported, stick next to the rest of it right there. It'd be interesting to take this back to the lab and see if this clicks onto the end. And we've got a nice vertebra right here too. Check that out. Beautiful vertebral centrum right there. This is one of the backbones. Right here. So I've actually, believe it or not, never worked at a site that's this dense with dinosaur bone. It's just incredible. This is what you get when you've got hundreds of dead ankylosaurs that all somehow got washed in together like this and buried. This is a real challenge to work this site because it is so incredibly dense. Normally you want to trench around the bones so that you can safely extract them, usually with like a field jacket with plaster-soaked burlap. It's really difficult to trench around these bones because, say you're trying to trench around this rib, so you're digging around it and then right there, another bone right here. It's just everywhere. It's illustrated by this site here. It's wild. Generating Views jokingly says, those dinosaurs are pretty stupid for dying. I don't plan to. Good luck with that. I hope it works out for you. But we've got questions about how big their brains were and what the dinosaur was. It's for Gastonia, this particular kind of dinosaur. It's an ankylosaur, and ankylosaurs aren't known for having particularly large brains. Here, I'll go out to talk about this for a bit. So, determining the intelligence, however you try and measure that, I guess. I don't know, what even is intelligence? But, trying to determine how intelligent different non-avian dinosaurs were back in the Mesozoic is tricky. Often the best that we can do is look for evidence of complex behavior in the fossil record, which is tricky in and of itself, and also just look at brain size. So the lucky thing is that in reptile skulls, generally you can get a pretty good idea of what size the brain is and what shape it is by looking at the endocranium. So looking inside the brain case, basically. So the brain case is like a bony little box inside of the skull that encases the brain. And so if you open that up or if you CT scan it and you look at the shape, you can figure out, well, shoot, this is the shape of the brain. And that can give you really interesting clues like, okay, this animal had really big olfactory centers, so it must have had a really good sense of smell. Or it has big ol' optic lobes indicating good vision. Stuff like that. So there's a surprising amount that we can determine, but how does that translate into intelligence? I feel like we've got a pretty hazy, incomplete idea of how intelligent many modern animals are, ones that we can observe alive today. So good luck with a lot of these extinct animals. It's a lot trickier when they're no longer alive. You can't observe them in the wild or in the lab. But I'll put it this way, I guess for our intents and purposes here, dinosaurs were as intelligent as they needed to be. This is a remarkably successful group of animals. They were the dominant terrestrial vertebrates for like 150 million years. They lived on all 7 continents on our planet. Just about anywhere on land, dinosaurs are the big critters walking around. Both as carnivores and as herbivores and just about everything in between. And so, even if we can't tell directly, like if we can't give them an IQ test or something, we can go, well, shoot, they were certainly smart enough to survive and thrive for a very, very long time. And we have a pretty good idea that dinosaurs were the smartest animals in their world. So, our ancestors, little mammals, little squeaky mouse-like critters that produced milk for their young, you know, mammals. During the age of dinosaurs, there were mammals around, but they were almost universally very small. So like mouse-sized. That's kind of your general range. The biggest ones were like the size of a big badger or something. The smallest ones were like almost insect-sized. They're tiny, tiny, tiny. And they don't seem to have been particularly bright. We think that dinosaurs, the most intelligent of dinosaurs during the Mesozoic era, almost certainly would have been more intelligent than the most intelligent of mammals. So dinosaurs were the geniuses of their time. But yeah, exactly how smart though? Well, how do you measure smarts? It's a tricky question. And yeah, but we do know, we've got good evidence that dinosaurs, many of them were social animals, so they lived in groups. They may have had complex social hierarchies. We've got lots of evidence that dinosaurs would have had, visual displays, crests and horns and frills on their heads or on other parts of their bodies they would use to show off to one another. This is not really the domain of animals that you should think of as stupid, These are probably, animals that exhibited complex behaviors. So they were certainly smart enough, and smarter than our ancestors, most likely, at that time. Does that make sense? Yeah. And when did giant sloths hang around? Way more recently, hamster rain. Like, basically last Thursday, geologically speaking. Like, the ground sloths that were walking around in North America, they may have gone extinct because humans who showed up hunted them to extinction just like maybe 10,000 years ago. So like really recently. So like potentially after the invention of alcohol. I'm not saying that's related. It's not. But like we've got evidence of people inventing alcohol around the same level, like 9,000 years ago, something like that. That's around the same time that the ground sloths went extinct in North America. Along with the mammoths, American camels and horses and critters like that. Does that put things into perspective? Ground sloths, they should still be around, They were just here a few thousand years ago. Whereas the last of the dinosaurs, except for birds, the last non-bird dinosaurs died out 66 million years ago. So, puts things into perspective, right? Yeah. And thank you, Racodactylus. I really appreciate the 18th month subscription. Thank you, Reiko. Good stuff. Yeah. Anywho. What's the estimated age of this site? This is about 130 million years old, we think. So we'd be in the poison strip member of the Cedar Mountain Formation. So, and I think that would be, this must be the Ruby Ranch above it here. Which I think is this kind of like deeper gray right there. But yeah. Hey Michael, is that the Ruby Ranch up there?
I believe so, yeah.
Okay. I've been saying that, but I think...
Poison Strip, Ruby Ranch, and then we skip Mustn't Touch It here.
Right.
And go up to Natarita.
Right, yeah.
That's that capping.
So the capstone is the Natarita up there.
And I believe that is essentially correlating to Western Interior Seaway Rise.
Yeah. I think it's like an estuarine environment there. Deltaic, yeah. Cool.
So
Thanks.
It's a big change.
Yeah. What do you think of these clouds?
Pretty cool.
I think it looks like it's gonna get us. Big old rain curtains. Shoot. See that time lapse if Michael decides to show us. That's gonna be neat. Yeah. Very cool. And anywho. And Digital Deck says, I heard an interview of a guy who wrote something about the word genius and how it's not a thing you can classify, it's a culture thing. Exactly. Yeah, it's pretty subjective. That's why we don't really use that term that much in science, because what does it even mean? You can't really define it. As scientists, we're big into trying to be precise with our language, especially when we're talking about scientific ideas, because we want to make sure we're talking about the same thing. Have you ever had a conversation with somebody that turned into an argument, and at the end it just turned out you're in agreement, but you're talking past one another because you kind of didn't agree? In science, we do our best to try and avoid that. You can't always, sometimes it happens, but we do our best to try and make sure that we're all on the same page when we're having a discussion. We try and make sure that the words that we're using mean the same thing to each of the people in the conversation. Yeah. I have thoughts on that because I do know some corners of science that still like to use that language. Yeah, but we know what they're like. That's it'd be fun to talk about that on stream sometime, Reiko, if we do another collab. Yeah. But yeah. Anywho. Daily Daspis, do you think there's a fossil in that high ground? There certainly are, Daily Daspis. Yes, certainly. So we've got fossils from the Ruby Ranch, remember? Of the Cedar Mountain Formation, which is the kind of like reddish, grayish bands running through there. And then at the top, you've got that brownish, yellowish sandstone up there. So that is the Natarita Formation. And I think the Natarita is exciting. There's not really, I don't know if there's any dinosaurs that have been named from the Natarita Formation. So that is the environment there, represented in those rocks, is like coastal delta. So that's when the western interior seaway is starting to move into the interior of the continent. You're starting to get this big influx of seawater as sea levels rise during this time. You've got, here we go. Let me find that for you. There we go. Here is about 130 million years ago. This is what North America would have looked like. There's Utah right there. So we're about right here. But then fast forward in time to 70 million years ago. That's not when the Natarita is, but at least it shows the western interior seaway. It's after the Natarita. But you get this big seaway that forms in the middle of North America like this when sea levels rise. You get all kinds of cool oceanic animals that show up in the fossil record then. Lots of fishes, like, you know, you get sharks and things, you get ammonites, you get all kinds of cool critters, plesiosaurs, mosasaurs, sea turtles, all showing up in the middle of the continent. So like in Kansas, you get sea turtles, giant ocean-going plesiosaurs and mosasaurs, things like that. Yeah. So that, this kind of, when that seaway first shows up, when it starts to come into North America at this time, you know, it comes in bit by bit. And then here in Utah at this time, this is going to be what, like 120 million years ago, something like that? I'm guessing. I think it's about 120. That's when you get those rocks forming, the Natarita Formation. So when the seaway is just starting to encroach on this area, so that's coastline up there. This is like delta environments. This is, you know, when you get rivers dumping fresh water into the ocean. That kind of fresh and salt water, that's what's represented up there. And that's exciting to me because dinosaurs, among other kinds of dinosaurs. We don't have any Spinosaurs from North America, but we do have rocks that are the right age and the right type to hold Spinosaurs. That's the Natarita Formation. If we're going to find any Spinosaurs in North America, chances are it's going to be there in the Natarita. So far we don't have even a single tooth or anything, but if and when they're ever found, if Spinosaurs ever make it to North America, we know we have them from South America, Africa, Europe, Asia, potentially Australia. None from North America yet, which is odd. If they show up, it very well might be in the Natarita. It's the right environment for them, and it's the right time. It's right before they go extinct. So that might hold North American Spinosaurs. Who knows? It needs to be explored further. Yeah. And there you go, Crimson. Yeah, that's exactly what I was saying. I need to be following chat more closely. And Reiko says, are there any plans to prospect there to find any valuable dig sites for Spinosaurs? You know, we can ask Josh, I suppose, if you'd like to. Because if anybody does it, well, shoot, it might be Josh. Yeah. So since the Prehistoric Museum does such cool work out here, yeah, and we'll ask him about his thoughts on this incoming storm too. We'll wait a minute though, because he's busy packing things up, directing people. Yeah. And let's see, what did Trombone Dalek says? I didn't expect there to be so many reference materials at a dig site, but it makes sense. No, these are mostly for stream, but I do have some that are actually for our use in the quarry too. Like I've got the original paper describing Gastonia lori-mcwhiniae. We were referencing that earlier. We're trying to figure out like what are these particular bones? Let's look. You know, what does the fibula look like on this animal? So we were looking at the figures published in that paper, and that it's nice to have. You can just compare it directly to the bone there. Yeah. And there you go, Casey. Yeah. This is how it goes in the field. You can see how much rain there is down there too. Like you can see that giant rain curtain of it. It just becomes so hazy. Some of that is going to be rain, and some of that is going to be dust kicked up by the wind. But it could be something. Are we thinking about packing up? What do you think, Foreman?
This one may go south of us. I've been kind of watching it.
On the radar? Okay.
Yeah, we're gonna get the edge of it for
Yeah.
sure. But yeah, the main little storm it was definitely west, and now it's kind of southwest of us, so it's gonna go around us.
Okay.
Thankfully, the worst one is to our north.
Oh yeah, that's hitting the book cliffs pretty hard. It looks like.
Yeah. This one, I think we're gonna be fine.
Do you want to pack up the tarps so they don't get ripped?
I think they'll be fine.
Okay, cool.
Yeah, they've still got good eyelets on them.
Nice.
The only ones I might have staked in directly into the ground.
Yeah.
Those have already ripped one pin up, so.
Oh, gotcha. Yeah, I see that there.
Yeah,
in the
with
corner,
this
yeah.
one getting close, the ones up top are fine.
Yeah.
But then, the white tarps that are staked into the ground.
Sure.
Pull those up.
Yeah, we had a question too about the Natarita up there.
Yeah.
Do you know if anybody's out there prospecting for Spinosaurs? I remember. So Jim talks about that all the time, as you know.
Yeah.
Yeah.
In the tropic shell.
You don't think it's likely?
Nah.
I mean, I would imagine we probably would have found a tooth or something by now, and
you
there's
would've
just
found
nothing.
it. I mean, the thing is too, there seems to be, oddly enough, a bias against large theropods in the Cedar Mountain, or at least yellow cat, poison strip, and even Ruby Ranch. Like, we've got some Acrocanthosaurus teeth in the Ruby Ranch, but there are very, very few remains of large theropods in the yellow cat and the poison strip.
Right.
It's all maybe an isolated tooth here and there, toe bone here and there, but in most formations in the Cretaceous, it's a bias against the small theropods.
Right. Yeah.
You're like, where are the raptors? Where are the ornithomimids? Those sorts of things. And that's right the opposite here with us here. That dust is blowing up. I'm gonna drop these tarps real quick.
Yeah. Let me help you out. Set the camera down. Hopefully the camera doesn't get blown over. I'm gonna grab my dust and wind goggles too, real quick. Be right back.
Yes.
In my car.
I've got a healthy obsession with cheeseburgers because it's Trump. So it's kebab and hamburgers.
Nice.
And I just think cheeseburgers are really funny. So I've got like a cheeseburger blanket. I've got a cheeseburger blow-up toy. I've got a cheeseburger. I've got an ornament from my friend who got me. Yeah, the cheeseburger blanket, cheeseburger ornament, cheeseburger slippers. Yeah, little cheeseburgers. We just think they're so funny, my friend Dan and I. Oh, hamburgers. Hamburger.
Yes. Smush it down. Rocks on top.
Let's see.
I don't know.
Oh yeah. That's gonna be bad.
Oh, with Steve Martin.
Yeah, that's the guy.
All right,
I
just
was,
these
like,
ones going down to the
barely
ground.
conscious at that point.
Okay.
I don't know why it's my brother.
Yeah,
I'm 27. So I was,
the mesh
5
ones
at the time.
are fine.
Okay.
They're fine.
Yeah.
That's so funny because
Yeah,
like,
these.
The other, we're gonna do
because
the
it
other
doesn't
one.
seem like that much of a
Yeah, the
difference
ones
between
are
27 and 37.
structured.
But like,
It's so much.
but
It's such a
yeah,
difference.
it is a difference because like, you know, when I was
Yeah, we can see that dust coming in.
I mean, that's
Look at that.
Just the ones going these two right here. Yeah.
Yeah, that is something.
That time lapse is gonna be killer, man. I know.
So we might have to wrap this up pretty soon.
Over that hill over there, and Now it's full tilt like a Peterbilt.
Yeah.
We'll see. We're all gonna wish that we closed up all the windows on our tents. So it goes. Need any help or you got it?
I think we've got this one.
All right.
Sidewalk down or no?
No, those are.
Well, this one might get torn up. The
With the
that piece of rebar going through. Yeah. So let's take that down.
That is a good call. I forgot about that rebar. Although it's got the little safety button. So
Yeah, I don't know if it's gonna stay on there though. I just plopped it on the top. That thing's mostly broken now.
Yeah, if you want to grab that toggle ball over there,
Okay.
and then we'll just fold this back on the other side of the rebar.
Yeah.
All right. I have the equipment here since it's on the other side of the hill. You think that'll be fine?
Yeah. Maybe throw a.
Something over a pick or something?
Yeah, go grab a couple of them shovels, Danny.
Yeah.
And we'll throw one on top of the tarp, and then one on top of this. The reason I'm not worried about the tarps up top, those toggle balls are taking a lot of the elasticness.
Yeah, yeah.
You know.
If
So-
they were rigid or something, they'd tear, but they've got some flexibility.
Yeah. And if I'm wrong, we'll know.
Yeah.
We'll know better next time.
Pack up my.
Yeah, man, I hope I've got my tent stakes were going into this solid poison rock. So yeah, it wasn't great, but I think that side of my tent where the wind's coming from, it's way down. We'll see. I may just have to put it back up when we get back to camp.
Yeah. And I don't have all this grommet stake down for mine, so hopefully it's okay.
What's the plan now? We're gonna
Huddle in the
hop in the
trailer.
truck,
You could huddle in the truck.
pass over.
I mean, honestly, I think the worst is just going to be getting sandblasted. We're not going to get.
It looks to our south.
Yeah. Well, that's why I wasn't too.
Yeah.
Just figured we'd drop these side tarps at the end. But, yeah, I think we're going to get sandblasted.
Yeah.
If you got goggles, put them on.
Yeah, to stay dry, we'll be fine just getting under a tarp. Yeah, how long ago getting in the truck?
There, I think it's. I think it'd be wise to wrap up the stream right now before the storm hits. So we're gonna find somebody to raid into, and we'll wrap this up. So hang on just a second, chat.
You go huddle in the truck if you want.
I'd be out of range of the Wi-Fi, so it'd be.
Yeah.
So I'll go ahead and wrap up the stream. Maybe we'll start another one later. We'll see. But for right now, who else is on? Let's see. It's been a long time since we've raided into Moo Hoodles, so let's do that. Beautiful. All right. She's interviewing somebody from NASA right now, so that should be pretty cool. Anyway, thank you everybody for tuning in, watching today. Really appreciate you. We really got to wrap this up. So yeah, let's go raid in right now.
Never mind.
All right, goggles on. All right, everybody. I got to go help out. See you later.